In this video, we are interpreting rates of change graphically. So before we begin, we'll just do a recap of what the sign of the first derivative and the sign of the second derivative mean. So in terms of the first derivative, remember if it's greater than 0, the graph or the gradient is increasing. If it's less than 0, if the first derivative is less than 0, it's decreasing. And if it's equal to 0, there's a stationary point. Now, when we're talking about the sign of the second derivative, remember this is in terms of concavity, like concave upwards or concave downwards. So if the second derivative is greater than 0, it means it's concave upwards, which means the gradient is increasing as we go from left to right. Now, if the second derivative is less than 0, it's decreasing and it's concave downwards. So as we go from left to right, the gradient is getting smaller. Now, if the second derivative equals 0, there's a stationary or point of inflection occurs. So on your screen, you have a graph and we need to describe the sign of the first derivative and second derivative. So the first thing you notice is that the graph is increasing and it's going from left to right. So we can say that the gradient is increasing. Sorry, the gradient is positive first. So we're talking about the first derivative, so the gradient is positive, which means our first derivative must be greater than 0. Now, the second thing we're looking at is what's happening as we're going from left to right in terms of the gradient. Now, if you draw off little tangents, you can see that the tangents are getting steeper as we go from left to right. So what that means is that the gradient is increasing, and when the gradient is increasing, we know we have concave upwards. And what this means in terms of your second derivative, therefore our second derivative is also greater than 0, because if it's concave upwards, remember the second derivative is bigger than 0. So if we look at this one here, this time we look at the gradient and it is going from left to right. So we can say that the gradient is still positive, so is positive, which means that the first derivative, so dy dx, must be bigger than 0. Now if we look at if we draw our little tangents again, you can see that it's getting smaller as it's becoming closer to the horizontal. So we can say that the gradient is decreasing, which means we have a concave down. And remember, when you have concave down, your second derivative is less than 0. All right. So again, gradient was positive in this one, so the first derivative was bigger than 0. But the gradient looks like it's decreasing as we're going from left to right, so therefore the second derivative is less than 0. So here we have a question. Inflation is increasing, but the rate of increase is slowing. We need to draw a graph to show this trend. All right, so the first thing I want to take note of is the question states inflation is increasing. All right, so what this means for us, this means that the gradient is increasing. The gradient is positive, positive. All right, if inflation is increasing, the gradient is positive. But they also mention that the rate of increase is slowing. What that means in terms of the gradient, the rate of increase, is slowing. So what this means in terms of the gradient is that the gradient is becoming smaller. And when the gradient is becoming smaller, this is an indication that it is concave downwards. So we know the gradient that we are going from left to right, we are going upwards in a motion going up, but we are starting to slow down, all right, and getting closer to being a horizontal. So we are going up, but as we're going up, we're getting closer and closer to a horizontal. All right. So what this graph I just did represents is exactly what we said. Yes, the gradient is positive, and as I draw tangents coming off here, you can see that the gradient is increasingly getting closer to the horizontal or smaller. Therefore, it's concave downwards. So that there is our inflation graph. So now we're looking at a population question. So we have a population of rabbits, and this was studied over time. And at the start of the study, there was 2,500 rabbits. During the study, the first derivative was less than 0. So what does this mean about the number of rabbits during the study? Okay, so again, we're saying that dp dt, so all that means is the population over time is less than 0. And remember, dp dt is in relation to the gradient. So if it's less than 0, we know that the gradient is also negative. And when a gradient is negative, it means we're decreasing in population. So the population is decreasing. Because it's going downwards, it's a negative gradient. Next part, if at the same time we have the second derivative, which is greater than 0, what does this say about the population rate of change? So, dp over dt squared is less than 0. And remember, this is in relation to the rate of change. All right, so what's happening to the population? Is it increasingly getting smaller and smaller, or is it starting to slow down and plateau? So, what this means is, remember, if you have a second derivative which is greater than 0, this means it's concave upwards. All right, so if I had to graph something, it looks like we're going down really fast and we're starting to slow down. All right, not as many rabbits are disappearing. All right, so what this means is that the rate of change, all right, is increasing. Okay, so now sketch the graph. All right, so some points we need to put in. We've got P over here for population, time down here. We know we have a starting point in the question because it said we start with 2,500 rabbits. But remember, it was negative, so we should be going downwards. But remember that the rate of change was increasing. So what that means is we're going downwards, but as we're getting closer and closer, less and less rabbits are disappearing, and we're starting to plateau. All right? So as we're going from left to right, we are going downwards, but the gradient is starting to plateau. So to recap, this is just a recap of it, what we kind of covered in some of the important parts. So remember, you're using both the first and the second derivative here. So it's important to note that the first derivative is in relation to the gradient, remember? So if the first derivative is greater than 0, it's increasing. And it's a good way to think of it in terms of population. So the population is getting bigger if a gradient is greater than 0. Now, if it's less than 0, it's decreasing. So again, if your term's in population, that population is getting smaller. Now, the second derivative just helps us with the graph and how quickly the population's changing, what's happening to that gradient. All right, so if it's bigger than 0, we know that the gradient is increasing, it's concave upwards. If it's decreasing, it's concave downwards.